Hi all, I hope everyone have gone through the yesterday's SQL Bootcamp Day 1. You would have learned about the basic core concepts of SQL. Today we are getting into to learn about the advanced concepts that are required for data analytics and data scientists. Here today we'll be covering the topics like subqueries, window functions, and main concepts in window functions like how ranking, how row number is being used. Then we are going to look about the common table expressions, and also some of the joins we yesterday discussed about it, but here we are going to discuss about an advanced join, which is a self join. And as discussed about null handling yesterday, today also we'll just refresh it out, and combining lists like using union, what is the difference between union and union all, and some of the date and the string manipulations they are going to look into it. So here today I'm taking a data model which is having data sets like customer, their deliveries is the fact table here, and customers are and restaurants are the dimension table here. So I have already discussed what is a fact table and what is a dimension table. To put it short, fact table is like an event table where the events happen, which consists of all the details about an event and people participating in that and the tools that are being used in the event, the information about the tools and the people, these from the dimension table. So here it is deliveries, and delivery becomes the fact table and customers and restaurants become the dimension table. I have put it in short to make it easy right now. So here first we are going to see about the subquery. Before that, let's look into the data sets that we have. Let me run all these comments to see the set of data set. See customer, we are having customer ID, their name and the sign up date and their preferred cuisines. In deliveries, this is the fact table. It is having all the customer ID, product, restaurant ID, and even the driver ID. And restaurants is having the details like the restaurant number, ID number, their name, their cuisine, and the city it is located. So first question is about query, subquery. First, what is querying? Querying is like questioning the database. In simple English, it is like questioning. We are all the things that we are did till day is like questioning the database. We have questioned the database about something, and it just derived the data that was related to that particular question. In SQL terms, questioning is querying. So subquery is like query inside a query. So we are having a main query inside which we need an additional support of another query in order to make this particular result that we want, that the business needs. Okay, so it will be mostly used with where clause and another select clause or a select clause, so that we will be able to derive the particular business KPI values. So for example, here we are doing like the we are here to find the order, okay, whose average delivery time is greater than the total average delivery time. So first let's divide this question into two halves. Here we are having two tasks to be done. One is to find the average delivery time, which we have seen yesterday by using aggregation. We will see that today also, and then we have to compare it, and then we have to compare that particular delivery time with other orders each separately and get out the orders that are exceeding even the average time. Okay, so here out of this result you will be able to find the orders that are delivered late. You will be able to find the orders that are taking then the average time of all the deliveries that you have done. It will be able to find you the outliers also. So first let's check out the average delivery time. Let's go step by step. Okay, so here I have already written the query, as you all know. Okay, we are selecting the average delivery time. It's simple, we are giving it as an average delivery. Okay, average delivery time, let it make it as time for delivery. So the time is in minutes. Okay, so we'll be getting our answers also in minutes. So you are able to see 29 minutes. Okay, it is the average delivery time. So here our point is to compare this with all other orders, that is all other deliveries. Okay, and to find out those exceeding it. So here you are able to find 29 is the average delivery. Here delivery 1 is taking 35, and Delivery 2 is fine. Delivery 3 is taking more time. You are able to see the things that are taking more time. So it's our duty to get these result in a separate query. If you are going to check this, it is easy for you to check this 12 values, but your business would need you to work with thousands of orders that would have placed in one day. So let's check that out. So we are going to select all things. Okay, we are going to select all the columns from deliveries. Okay, we are going to select all the columns from deliveries where, okay, delivery time in a minute is greater than. So greater than, here we have to have a condition. Greater than what? Greater than this particular average time. We have no need to mention this. I just wanted to make sure. Okay. Here you are seeing that we are using it with where. Okay, where we are going to get the delivery time which is greater than, which is greater than the average delivery time. So this select average delivery time, from it has to know from where it has to select. So from deliveries you will be getting the total average labor time, that is the 29 minutes. It will be comparing that with all this and will be providing the result. So okay, let's run this query. Yes, you'll be able to find this. If you are able to find this, you will be able to find all the delivery times that are greater than 29 are being given. This is how a subquery is used. This is the main query. The first select star is the main query. Here, along with the where, we are using a query inside that, which is the subquery. Query inside the query is known as the subquery. Fine. Let's next move on to exist. Before that, you are able to see another example, like where customer ID. You can also see here we have used one condition. Like yesterday we have seen in clause along with the where clause, right? Where after in you will be giving a set of hard coded numbers or alphabets or something, or cities. Okay, here you are going to make that difference. Okay, here instead of hard coding those values, you can use in function, and you can you can use in and provide a subquery from where it will get the required customer ID or the date, and it will be using that set, and if anything is present in that particular set, then it will be returning it out. You can just try it on your own. By using in, just take an example, go and chat with ChatGPT, get an example query alone, try to sort it on your own and find if your answer gets the perfect result out. Okay, let's move to the subquery second part. Here we have already seen it is going to come with where clause or select clause, and using in also. Here comes something else, exists. Okay, exists, as its name says, whether it is present or not. So if you want to check, for example, here if you want to check, we have a customer data here. Okay, customer data here, and if you want to check they have placed any orders. Maybe the customer would have logged in but they have not placed even a single order till date. Things can happen like that too. People would have churned out, that has moved away from us, so we can check that also. So exists give you an idea, like you are going to compare a two table or same table. You are going to just do something like you are going to find whether it is present in another table or not, right? If it is present, it's going to give you true. If it's not, it is a boolean check. Okay, so here exist returns true if the subquery returns any rows. It can be 1, 2, many number of rows. It is often faster than in. The in condition that we just spoke about, it is faster than in. It stops checking once the first row is found. If something is found, it is present, so okay, the condition is satisfied and it will move. Okay, it will give the give that particular responsibility. Yeah, I've checked, we're having one row, it's fine, you just move on with the next outer query. Okay, here we are going to see list restaurants that have ever had an order existing 100. So existing rupees 100. So first, this is the okay, this is the restaurants. Okay, so here we are going to select restaurant restaurant ID and name from restaurants. Okay, we are going to compare it with, okay, we are going to compare it with a where condition. Okay, where we are having the deliveries are here. If you run this, you'll be able to find the deliveries. Here also you'll be having the restaurant ID, so it's going to match on the restaurant ID. So they are asking where amount greater than 100. So clearly you can see that only one order is being shown. So okay, then it is a decimal value, I think, so it's better to go like this, where amount is greater than 100. But here you will be getting a confusion, right? This is present there and that is present. How are we going to match? Just writing this, it's really going to throw you an error. That's where exists come. Okay, so where, okay, here you are going to where exists. Okay, so here you are going to write a select query. Here you can select even one. Okay, select one is going to give at one row. If it is okay, it's okay. Okay, select one. Okay, here you can write a where condition. Okay, select one from deliveries. Okay, where what amount greater than 100. Okay, are you getting me? Like we are going to select it. Okay, they have used a where condition where we have to first we have two conditions. One is the one first we have to match those two, and second we have to check the amount. Okay, I will check the amount. Here we are going to match it out. Sorry, here and okay, this is an uncondition. And wait, here it is going to be delivers, we're going to have it as D, and restaurants we are going to have it as R. Okay, fine. So where two things that's connecting it both, as I've already discussed, it's the restaurant ID. So D dot restaurant ID is equal to R dot restaurant ID. Okay, these are the two conditions that has to be satisfied. These two conditions are the things that are asked. List restaurants that have ever had and ever had at least once it has had, it's fine. Okay, so we have did it and just we will run it out. Sorry, we didn't see what was the restaurant name, right? So deliveries, which was that 110, we didn't see that. Okay, 110, it was R005, and okay, it's R005, and if we run this, you are able to find that particular thing also. It's matching. You are able to get that R005 weekend delayed as only you had an order that was greater than 100 and was greater than 100. Is this fine? I think I will explain this once again. We had many things going on here. So here we will be first selecting the ID. Here we are going to work with two tables. Okay, one, we are going to check whether even a single row exists with the conditions that I say. I'm fine with it. So exist works like that. So here it will be in this inner query. This particular inner query is going to return you. Okay, this particular inner query is going to return you with a restaurant ID back. You will get the restaurant ID back, and it says this will be giving you a true value only for that particular 110. that R005. So that R005's name and name and the ID will be fetched from the restaurants and will be established to you. This is how the subquery query inside a query works. If you have any doubts in this, just please comment it, and I will just take you through each step if you are not able to understand. Then we are going with the common table expressions. These subqueries inside queries we use mostly, but in order to increase the readability, we just put it into a separate CTE, which is the common table expression. Not to make it more complex, we have seen two, like sub query into a query. We have seen there may be query inside, there may be 3 to 4 queries inside a query. There will be more branching of subqueries even present. So at that moment we have to move to CTEs to make it more readable. Even someone else who is going to the particular query will able to understand the particular thing. So here the use cases, when your logic needs to use the result of a subquery more than once. Okay, more than once. If you make this CTE possible, like example here they have made a CTE, they have selected a column, they have counted total orders from the deliveries and they have grouped by one is like, if you mention the number 1 2, what it is going to do is, it is going to check the first column that you have mentioned. 2 is going to be the second column. Okay, don't get confused in here, as we are just writing the columns names yesterday and today. That is the better thing, because it would be even more readable. Okay, this is the CTE we have created. Okay, we have given it a CTE underscore as. Okay, so in order to get something from this, will be holding a table. This is a table that is holding a value as per your conditions. Here it will be holding the name and the number of total orders that particular customer has placed. Okay, then we can write a main query, like always we use right, select star from that star. Now we are using this particular table, so you will be marking to this particular table and we will be working there, where total orders are greater than 3. We have 2 columns here. One is going to have the name, another one is going to have the total column, total order. So it's easy, so that you can easily work on it. So here, find the average order amount for customers. Okay, find the average order amount for the customers who placed above 2 orders. So again we are going to divide it into 2. Find all the customer ID that placed 2 orders. That is the CTE that we are going to do. So let's do it first. Again we are going to work with deliveries. Okay, here you are going to select customer ID, comma, count of order. Do we have any order ID here? We have delivery ID. Okay, these were the things that we discussed yesterday. Okay, so if we are going to use an aggregation, we have to group them. So we are going to group by the non-aggregated column, which is the customer ID. So as a result of this, you will be getting the customer ID along with the number of orders they have placed. Okay, so here you can see 201 has placed 3 orders, 202 2 orders, 3 1 order, like that. Okay, let's run this. Again I made a mistake. I think let me pull this output out. Select customer table booking. Okay, I am always committing a spelling error in this particular thing, so that is the reason things are getting bad. Okay, always try to keep the names better. Okay, that easy to spell also, so that you'll be able to work. So as we have discussed, we are able to see each customers. So first they are asking only for the customers who have placed more than 2 orders, greater than 2 orders. Then we are going to get just 201. Okay, So having count of delivery ID greater than 2. As a result, we will be getting 2 not 1 alone. See, they have got. So the first thing we have did. Okay, this is what we have did. Okay, we can see this is the thing that we have did. So we are going to place it into a city. Okay, so placing this particular query is, you are not going to do anything much. You are just going to have this. You are going to use a with condition. Here the with high CTE. Okay, with high CTE as. Okay, CTS, and here going to open, close it, open and close it. That's all. This is how the table is created. So here we have did the first part. Second part is find the average order amount. So they have placed that. So what was the average amount that they made? So average amount, as usual, we are going to take it from the deliveries, and we are going to just join this table where we are going to connect the customer ID of both the tables. So you are going to select customer ID. What are they asking about? That's something that we have to be clear. Calculate the average amount. They are not asking about any customer ID. So average amount is not present in us. It is present only in the table. Which table it is present? It is present in deliveries. Okay, select average amount from deliveries. Okay, for we are having we are going to join it with this, join it with the high CTE on, both are going to have customer ID. So we have to give an alias name, and it can be D. So D dot customer ID equal to H dot customer ID. So you'll be able to find what is happening here in this particular main query. Here you are going to get the average amount. Fine. From the deliveries. Okay. So they are going to join with this. Why we are going to join? If you are going to just run this particular query, you will be getting average amount of all the people. But you want to know for exactly want to know for the people who are having higher than 2 orders. So if you try to run this, you will be able to get that 43.75 is the average amount. If you want to round the amounts that you want, you can just use round. Okay, around things. The first parameter is the amount or the variable that you want to round, and next you can give to how many decimal points after after decimal point how many numbers you can have. Sorry. 43.75 is the average. Okay, average amount. This is working fine. Then we are moving to the window functions. Window functions are pretty much familiar and pretty much important when we are working and talking about the advanced SQL topics. So here window function, as it says, it is a window. Okay, when you are going to take a large amount of table and you need to work on a particular window. Window is like a particular block, or like what we have used in the group by. Okay, a particular group, for example a particular city, or for a particular rank, or for particular product. All these comes into the window. So window will be it will be a set of rows to perform calculations. So not on all, but this is the set I am giving. You just work with this particular set and give me the result back. This is how things are working. So here, if you are going to see about the analytical code, we have functions like average, sum, max, and rank. Okay, whatever we are going to do, we will be having a function, okay, continued by an over. over what over after over you are going to give the windows window, what is the window they are going to work on. So partition by, you will be giving the column names to it, and then order by the column to order calculation. Okay, I think it is fine. So here you will be able to see the first one, sum, average, max, min, everything are going to work under aggregation. Everything that we have saw yesterday was aggregation. Here the about the aggregation, if you are going to see, you will be able to see that we are going to use a particular aggregation for a particular window that we are going to describe. For example, show the highest delivery amount for a restaurant on every one of its order. So for a particular order, what is the highest delivery amount? You will able to see here that we are getting the delivery ID, we are getting the restaurant ID, the amount, maximum amount we are getting. Over what we are going to do is that partition by what? Their question is about partitioning by the restaurant. So partition by the restaurant ID we are moving and naming it as maximum restaurant order, and we are just as usual we are using this select function. Let me run it out and let me show you how this performs. Select delivery ID. Okay, we are going to select the delivery ID, restaurant ID, amount and maximum amount over a partition of period. Okay, so the restaurant ID, amount. So here you will be able to see as per each restaurant you will be able to get the maximum amount. See, maximum restaurant amount, you are able to see the amount of delivery 1 and you are able to see the maximum amount is 55. Okay, you can just order by the amounts or you can order by anything. That also you can mention here inside the over itself. Like here you have mentioned partition, no? Here you can order by, let's order by the restaurant ID. Okay, restaurant ID. See, you will be able to get the order also. So you will be getting the order. We can also order by the restaurant ID. Okay, that too works fine. So here you can do the partition as well as order by. This is the window over which we are going to do some functions, and this is the function that we have mentioned. This is how the aggregation functions work. Then we are going to see about ranking. Ranking, we have three main topics in ranking. One is the row number, another one is rank, another one is the dense rank. Row number is like number that are given to the particular rows, like 1, 2 and 3. You can mention over which it has to be given. For example, I have to mark the number of orders that are placed only for a specific month. I can go with row number and I can partition by the order date. Okay, if I partition by the order date, especially month of the order date, you will be able to get all the numbers from 1 to particular number which are made for a particular month. Okay, you can do that. Row numbers, row number is mostly used. So it is like assigning a unique sequential number to each row within a defined partition. So here also find the absolute first order by date placed by each customer. This is how they are going to do it, like one of the things that I have mentioned. Okay, they are going to select everything. Okay, here it is a subquery. Okay, it is a subquery we have seen with where clauses. We also saw it also works with the select clause. Here it works with the select clause. You are able to see it. You are going to guess the customer ID and the order date and row number. Okay, you are going to make row number over a partition of what? Customer ID. Okay, because we are going to find the absolute first order date. Okay, first order date by each customer. So the partition has to be done by each customer. So the partition is done by each customer, and we are going to order the date, order by the order date. Order by is like sorting, as we discussed yesterday. So it is going to be like order by order date ascending order, and we are going to give an alias name for it. After that, it is also after this is taken from deliveries, okay, and after closing that completely, we are going to make it as a ranked rows, and we are going to filter the first order, okay. Rn is something that we have given the name for the row number, so we are going to make it as the first order. Let's just do this in our query and just see how it's giving us the output. I'm just copying and pasting it out because in order to save time and not to make this particular thing a bit harder, okay, not to make it a longer video. Okay, it's fine. So there's a problem here. Let's check what is the problem. Okay, this was the problem. If you run it, it has to run. Yeah, you are able to see the rank it is giving. It has given rank 1 to all because we are just getting the things with rank 1, okay. So you are able to see if you are not giving any var condition here, select from rn is equal to rn in, we can give, and 1 comma 2. Let's see whether we are able to make ranks 1 2. See, you are able to get rank 1 and 2. So here in short we are going to give row numbers, okay, row number over the partition on which we are going to do any partitions, okay. It is going to be done in customer because for each customer we are going to find what is the first date they have done. So we are ordered that the order date in the ascending order, so that the earliest date comes first, and are marked it as rn, okay. These are also taken from deliveries, okay. Then from this thing we are going to, from this query, from this table we are going to query. So this query we are going to do it, and from there we are going to select everything, and we are going to take, for example, we are taken row number 1 and 2 as per the business requirements. You can use your var condition there, okay. This is how rank row number is just like the number of rows or the indexes that we mark, okay, 1 2 and 3. It will be a continuous sequence of numbers, but it will be done for the partition that you are giving, okay. If you are giving the customer id, the particular customer id will have 1 2. The customer id is over, then for the next customer id it again starts with 1, so you have to remember that also. So ranking here, ranking is like it's like the old school method ranking only. It will be ranked on the particular row column you are mentioning. It will take the values from the column and it will rank it randomly. If two of the columns are having the same, two of the rows are having the same value, it will be marking them with the same rank, okay. And here a problem comes with the rank. A rank problem is like that: if two of the datas or three of the datas are going to have the same number, for example here 1 is fine, 2 2, then for the next number you will not be able to find any of the data having rank 3. You will be able to find only rank 4. It skips the numbers that are already being used, okay. If 2 and then 3 has to be used, but for another data also it is using 2, so it skips 3 and goes 4. If there are 3 datas for position 2, it will mark all the 3 datas, and for the next data it will be giving it as 5. So if you want this, you can, if you are not going to worry about the ranking or skipping of the numbers, you are well and good, you can go with rank. But if you are worrying about that, then there comes dense rank. Dense rank is also going to do the same work as rank, but the only difference is that it won't skip number. Let's go with this particular thing. Here they are going to rank over a delivery time. Okay, rank over delivery time. So the then rank over delivery time ascending order. Okay, we are going to order by ascending order. So ascending order means delivery that is made earlier will get the first rank. Okay, so dense rank also is being done. Let's see what is the difference you are going to see. There's two particular things. Let me copy and then we paste it out. I think we can take another one. Yeah, this works fine. If we run this, select delivery time in a minute. There is a problem. Oh, I'm sorry, I've just copied half of it and I'm just okay. Dense rank. Okay, from yeah, fine. Thank you. So here is how it's going to do. Yeah, you are able to see it, right? In a rank, normal rank, it's going to rank. We don't have any anything that's repeated, I hope. 8, 9, 10. Yeah, we don't have any repetitions here, so it's okay, it's fine with it. But if it have repetition, let's go inserting values, no. We are going to insert into deliveries. Let's take this one. Copy and let go insert into insert into deliveries. Okay, let's go with the delivery date, the restaurant ID. Okay, fine. Then we paste it. I'm just making it as much short it can be. Okay, so values I'm going to take this value. Okay, here I'll just change this to 12. Date to 17, and here 30 is already present, so it is also going to be 30. This is how it has to work. And yeah, fine, just one data. Let me see let me insert it. Oh, I'm sorry, already there is. So let's go with 15. Okay, and let me run it back. Yeah, fine. Okay, so this is also having 30. Let's now run this query again and check. Yeah, you will be able to see now the clear difference now. For that particular purpose I've used it. So for 30 there are two things that are going to work with 30. So in time, just rank using positions, after 2 7s it's moving to 9. It has skipped the 8 because already 8 position is already occupied by a 7 itself. But when you see dense rank, when you are using dense rank, you see 7, it's continued by 8. It is not skipping the numbers. That's the difference between the rank and the dense rank. Here you can already you can see that rank we are making it over a particular window. The particular window you can also make a partition here. Here just you are using order by for making it simple. So we are going to order it by the ascending order. So the order with the lower time will get the highest ranking because it is very important that if the delivery is made it quick, it is good. So we are making it out, and also in order to compare rank and dense rank, we have just done it in both the ways, and we have taken this from the deliveries. Okay, I think fine with that. Let's move to the next one. We are just going to see about the lag function. Lag function access data from a row prior to the current row. So if you are currently working on, for example, if you are currently working on a particular row, like example, if you are currently working on the 18th row, you will be able to access the 15 value also. Okay, you will be able to access the 15 value. At that position you have to use lag. Sorry, that is the that is the way you will be able to use lag access data from a row prior to the current row in the partition. So current row you will be able to use, that is look backwards, where lead is going to make you to So with this example itself I will show you. 18 is the row I am currently working on. Lag is going to make me see 15 and lead is going to make me see 22. That's how it works. So here find the amount of the customer's previous order. So here they are using customer ID, order date, amount as the current amount, lag amount comma 1. So amount comma 1 is saying to go one step back, okay, over what, over the customer ID as previous amount. Okay, so these two are going to be, so it is easy if you see this particular thing as a table here. Okay, I think everything works fine, and let's check to this. Yeah, we are able to see here, no? We are partitioned it based on the customer. So customer's previous order and now what is the order they are making will all be visible here. So here you can see 201 first order was 25 paise. So before 25 rupees 50 paise, which before that they didn't make any order. So it is giving you null. And 201 gives you 45. If the before order is 25 paisa. 201 60 before order is 45. So you're able to see this. This is what lag does. Okay, if you are just replacing it with lead and run the same, the last value will be having null because it is not able to see the next value. Okay, this is going to be 1. Let's try this. Yeah, this is the number of rows it has to move up or move down. Okay, here I have given lead 2. So this, when it is in 25, it is checking 25, then it goes to 45. They have said 2, so 1 is completed. Next one, so 60, so it is pointing to 60. I think this works well. Okay, this is how lead and lag works. We have just completed both in the same one. Okay, fine. Then we are moving to the running totals. Running total is like, let me explain it simply. Okay, first let me just explain this particular itself. So for 25, okay, you're able to see 45 lead. Okay, lead is going to, yeah, lead, I'm using lead only, so it is going to see the next value. It is going to give me here. I will use lag here so that I would be even able to make it more clear when you are using a running total. So like running total also for 25, here you will be getting the running total as 25.50. But when the next amount is 45, here it will be an addition of 25.50 plus 45 rupees. So a running total, and again for 60 it will be an addition of 25, 45 and 60. For that particular customer, you will be able to get a running total of how much money have we spent till date. Okay, you will be able to get that. So here they have used order date, amount, sum. They are ordering, going to order it by order date. Rows bounded between unbounded preceding and current row as running revenue. Mostly the window frame starts at the beginning of the partition and ends at the current row. Okay, rows between unbounded preceding and current row is mostly used in the situations when we are using like a cumulative sum or something. Okay, so let's just see to it. Copy and let me paste it. Okay, I think you are able to see 25 is fine. 25, it is ordering by order date. Let's do with the customer ID. Okay, then let's see customer ID and order by customer ID, as we have been discussing that and we have written for that. No, it will be even more better. Order, that's fine. Okay, you are able to see now. This was the problem. This was the thing that we were discussing about. Okay, For 201, the first is 25. 45, 25 plus 45 is 70 point. So 60. So this till this it will be okay. After this customer has over, then it won't count that. So for second customer it will be starting. So sorry, it will be covering this also. It will be starting with this one. I think I have committed a mistake here. No, I have already said something in mistake, I think. Here it will be getting a running total is like that. You will be starting and ending with everything. So all the totals. So total, if you want to check whether the total is present or not, the complete total that you are getting and this total is equal or not, at that times you can use the running total. I made a mistake here, sorry. I have just said you that for the particular window here. No, it is not. It is going to just we are not partition it by anything. If you are going to partition it, you are going to get it, I feel. Yeah, let me partition by customer ID. Okay. Yeah, if you are, we have not partitioned it. Okay, the thing that I was talking about is with partitioning. We have not partitioned it. If you have partitioned it, see, after 201 it has stopped that running from, and from 202 it's going to start fresh again. So if 202 completes, 203 going to be fresh. So for each customer you will be able to get. But if you want to get a complete total and you want to check the whether the total that is present here in the amount as well as the running total is equal or not, at that time you don't want to use any partitioning there. Instead of that, I just use the order by and just sum it up. Okay, I think I'm fine with this. And let's go to the advanced topic, like one of the advanced joins, which is a self join. Self join is like, as the name suggests, there are not going to be any two tables. There will be just one table. One minute, let me check it. Yeah, everything is working fine. Here there will be only one table within which you have to make some joins and in order to find the answer. There are many interview questions. If you go through the SQL interview questions, you will be able to find that the employee table will be given, and manager or employee ID will also be present there. You have to fetch that manager employee ID, or else you have to see whether the manager salary is less than or greater than the people working under him. At that moment you have to use self joins. Okay, fine. So the first join, the self join, I think you guys are clear with the inner join, outer join, right join and left join. Here you are going to discuss about the self join. Okay, so self join is, as I already discussed, used when you need to compare rows within the same table. It requires aliasing the table twice to treat it as two tables. Okay, yeah, alias name we are giving while using join no for customer C, orders O. Here you are going to use if an customer itself, means make it as customer C1, customer C2. Okay, here you are going to use the find all pairs of orders placed on exact same date. So date is going to be same. Okay, order date and both in date is going to be same, and the delivery ID. Okay, A dot delivery ID is less than B dot delivery ID, so that it prevents duplicate. Because if both are going to be equal, okay, both are going to be equal, it's going to count them again and again. Okay, so that's where this step comes in. Delivery ID and order date. Okay, for only these two pair of orders placed on the exact same dates. So exact same date, two orders were placed. Okay, 12 and 15 was placed in the exact same date. Okay, 15 was something that we created out. So 12 and 15. So this is how it works. Like, we are going to work on that same delivery table. We are going to mark one as A delivery, one as B delivery, and the condition is going to be order date, and the delivery ID, one has to be lesser and one has to be higher. Okay, we'll be able to get the pairs. This is how the self join works. Then union and union all. You'll think why, where we have to use joins, where we have to use union, why are you going to union right now? That will be a question. Simple terms, if I had to say, if you are able to see two tables and you are able to see a column which is forming relation between these two tables, then you are going to have joins there, you are going to work with joins there. The situations where you will be using union or union all is the situation where you have two tables are looking similar, two tables are having the same columns with the same data types but with different data. Maybe this would be a month of November data, that would be month of December data. At that positions you can use union and union all. Union all is like you are just going to merge both without any, even duplicates are present, it will be merging. Union all will be giving you a clean set of table where it will be removing the duplicates. That's the only difference that is going to happen. Okay, which is easy. You are just going to use union on union all. So here first one also will be a select, and second also will be a select, in between which union and union all will be used. Here you should be very keen about the column names and the data types and the number of columns present in each of the tables. Okay, then comes the null handling. As yesterday we talked, we can use qualis. So we can use qualis. We can also use something like if null. Okay, if null, then same preferred location. Let me do it here. Let me do it. Let me just close this down and let me paste it. That's a problem in selecting. Here it has taken that name also. Okay, this is what is it going to do. It is going to select the name. Okay, first we have to check whether there are any customers. Okay, customers with cuisine, preferred cuisine, they have not preferred any cuisine. First we have to check that. Here you are able to see all our preferred cuisines. So let's add data. Like preferred cuisine is not being given. Let's insert a data like that. Okay, copy and insert into customer ID, name, sign up date. Sign up date, preferred cuisine. Okay, preferred cuisine. Values, like I will press this. Let's make it as 10. Let's make it as 10. Honey bunny, and they have not mentioned it anything. Three things. And let's run it. First, I think column count doesn't match. Okay, then let me make it as null. Yeah, things are fine now. Let's check. Let's now check this same cuisine. See, you'll be able to see someone with null. So now if you do this, the particular person, the honey bunny last one has got any, because that was null value which was replaced by any. So if I'm not going to do this, I'm just going to run it back again. See, null value. Here I can use if null also. If null is also something that can be used in order to handle. Okay, let's check this out. Yeah, so these are the two ways you can handle null. One is using if null, if null, but if null will just take two parameters. Okay, if null will just take two parameters, whereas qualis will take many parameters, many rows. If they are like for any of the rows that is present, you can just do it in one line for a higher set of data and many columns having null values, and for all the columns you are just going to mention it as NA or something that's common. So in that cases you will be able to use qualis. Okay, fine. Then this is how the null handling has to be done. Then we are going to work with the date and time functions. So date and time functions, similarly there will be order date. Order date is having all the date, month and year, and the date difference also. So date, month and year. So in order to derive it in SQL, MySQL, you will just use year followed by within brackets you can give the order date, which becomes the order year, month, date. Okay, it will be giving the particular date alone. So here they are going to check like a date difference. Date difference is a particular function that is used in date, which is followed by r. R is the output that we want. We want how much r. If you want how much date, you can mention as date. Day. Okay. If you want how many months, you can mention as month. Difference. It is like knowing the difference between the first and the last date. Okay. So order date, comma current timestamp. This is going to give you a results. How many hours ago was the last order made? Okay, last order made. This is how date functions are being used. And then comes string function, which we'll be using mostly in our data cleaning process. Trim is used to remove the leading and trailing spaces. Any spaces that are before the particular name or particular column data, it will be removing. Leading means before, or trailing means after. So any spaces that is present within that particular data will be removed if you are going to use trim. Okay, then substring is like you are going to take a particular string. For example, here you have this data, no, Butch college. You just want to take the first name alone, so that you can use like substring 1, 1, 2, 3, 4, 5. So 1, 5, if you give substring 1, 5, will just take the first name alone. Okay, it can be used in that situations. Concat, as you all know, concat is concatenation, making, for example, there may be data where you will be having first name and last name separately, like Boots will be separate and college will be separate. In order to combine them both, you can use concat. Concat, first parameter is the first name, and second parameter you can give the thing that is going to separate, a hyphen, a delimiter, whether it is a hyphen or it is going to be a comma or it is just going to be a space, and then followed by the next one that has to be combined. That is one of the example they have explained here. See the concat name, they are going to have a substring. Okay, substring like substring from the driver ID, which is going to be from 1 to 3, and followed as a driver tag. Okay, here they are giving a new thing for the driver. So the things that we have dealt well today are the ranking. Okay, you can use the dense rank to find these are the challenge that you can work on. If you want, I can even post about a project with these data that I will work doing, and a mini exploratory data analysis that I will be doing in order to learn more in depth for a particular thing. It is better to work hands on. That is the point. You'll be able to learn more things, and you'll be able to get more doubts on working. Either in syntaxes you'll be getting doubts, or else you'll be getting doubts in some other ways, in which place we have to use where I have to use having, why should I use join here, why should I not go with union here, which is easier. Like you'll have these sorts of questions. These questions and these sorts of questions can only be answered by not seeing through the tutorials, but by going through on our own. So this is also a part of my self journey. Okay, so that's how I am learning things. So here as the end, I just want to make this challenge also. You can have it is like the capstone project that I can do as a result of these 2 days, that you can post in your LinkedIn. You can also tag me out there. Here you will be able to see the first question is about, you can use dense rank. I have given what you can use dense rank and find the 3 fastest delivery per restaurant. We have discussed, we are going to just find the dense rank, and you are going to rank them and get the 3 fastest deliveries. Okay, so delivery time is the delivery time is going to be your okay, delivery time is something you are going to be concentrating on, and it is going to be per restaurant. So partition is going to be per restaurants. Okay, and order by is going to be deliveries. I have already given you the clue also. So calculate the day over day difference in the total revenue. So I can just order by date, and you will be you just use lead, so that you just use lag or lead in order to find. I feel it is better to go with lag, so that we can compare it with the previous day amount, and find the difference. So it will be giving the day over day difference in the total revenue. And you can use a common table expression to filter for customers with high value orders, and then calculate the average delivery time. High value orders are the customers who are placing orders more than 50, and then calculate the average delivery time that we are going to give. I can also give you another idea, like you just take high value customers, like someone who is giving you more rating. Okay, take them and see why they have given more rating, whether their delivery time was faster or not. You can just check to it. And nulls, find the average of rating of a driver, treating any null rating as 3.0. So here we are making at 3.0. It depends upon business needs. This is for an example. So you'll be able to find a qualis with it, and make that first term as rating of the driver followed by 3.0. So it will be replaced. Then you can go with the average function and work on it. So after completing it, you will be able to even have a portfolio ready project, which you can if you check through the data sets that are freely available. You can even do an exploratory data analysis with all of the concept that you have learned. If any problems, just do comment, and let me check with it. And if I'm not familiar with, I will just research it, and I will let you know, or else I will help you with it. Thank you.